Hey folks, I want to take you through the 5th R help and tips file. There actually isn't a lot new here that I'm going to have you use. There are a couple of extra skills here that I just want to give people if they want to use it outside the course. That's great. But there's some things here that I won't ask you to do in the course, but I want you to be able to have the resources to do it should that be necessary. So let's just go through some of these things and call it a day. So I'm going to use the NBA data like I've been using here. And I'm going to load that up and I'm going to look at it. And everything about it looks good. 30 observations, 29 variables. Great. So the first skill I have here, this is purely for your own use for whenever you might want to use it, is something called a find and replace function. So let's say, for example, let me look at my data for a second here. Let's say that under this conference variable, CONF, what if I wanted to replace all the E's with the name East? Or what if I wanted to replace all the W's with the name West? Or let's say, for example, looking at this playoff column, what if I wanted to replace the ones with the name playoff and the zeros with the word or name not playoff? So instead of going into my data and changing things one at a time, which you'd probably want to do in Excel anyway, because this, you can't really interact with this thing. But let's say you wanted to just quickly find something and replace it with something else. The command is called gsub, and the way it works is you type in gsub, and the first thing you type in quotes is what you want it to look for. Now I have quotes here because it's a character, so you should be able to tell it to look for a number and not need quotes. But feel free to play around with that if you want. The second thing you type in is what you want to replace it with. So I want to look for E and I want to replace it with East. The last thing is to tell it where to look. Because I know that I just want to make this change within the conference variable, I just tell it to look in the conference variable. Once that's all done, I want to tell it what new variable to call it. And so I just want to replace my old conference variable with this new replacement of E becoming East. So again, gsub, the thing that I want to look for, the thing I want to replace it with, and where I want it to look, and what I want that new variable name to be. So let's run this, and I can go to my data, and sure enough, all the E's have been replaced with East. I can also have it search the entire data frame if I take out the particular variable that I was originally searching for. So sometimes you may want to replace, say, all the zeros in your data set with something, or all the periods in your data set with something. You can tell it to search the entire data frame. But in this specific case, I knew I just wanted to search within the conference variable. Great, so that's that. Second thing is really fast. Remember in chapter 2 and what I talked about a little bit in the second lecture video about the confidence interval on our slope coefficient. Well, remember that a confidence interval, it just functions the way a confidence interval normally does. It gives us a range where we are confident that the true population coefficient in this case might be. So let me just look at my usual model output for a moment here. So I have a model I've run before. I want to predict the number of games won on average by using points per game as the explanatory variable. So I'll run that model, and I can go look at the results the way I normally do. And all my usual results are here, and make sure to check out or read through the Interpreting R Output PowerPoint file and video to make sure that you have a good handle on all these different things. So I have my coefficients here, and I have their standard error here. But what I would like to do is get a confidence interval, because remember, this is an estimate for the slope coefficient. This is a sample slope coefficient of 2.355. I don't know what the true population slope coefficient is. Maybe it's 2.355, maybe it's something else. Well, I can build a confidence interval around 2.355 so that I can know what the 95% confidence range is for the true slope coefficient, relating points per game to the number of games won. The way to do that automatically in R is to just use the command confint and then the name of the model I made. So when I run that, let me make some space here, I get this 2.5% to 97.5%. And I have my intercept and my explanatory variable. So if you notice what it's done, it's given us the lower bound on our confidence interval, the 2.5 percentile, and the upper bound on my 95% confidence interval, 97.5 percentile. So what it's giving me is the middle 95% of the distribution of each of these coefficients. And so I see I have a 95% confidence interval on my slope coefficient of 1.55 to 3.2. So we'd say I'm 95% confident that the true slope coefficient relating points per game to the number of games won is between 1.55 and 3.16. And if you remember a little something about confidence intervals, you might remember that the confidence interval, just type this up here, is equal to the coefficient, or the thing we're measuring, plus or minus what we use as a shorthand is 2 times its standard error. Well, we have all those things, fortunately. So let me give you a quick little demonstration. For points per game, my estimate is 2.355. And let's subtract 2 times, oh, we'll have its standard error right there. It's about 0.4. But I'll write out the full thing, 0.3944. And that gives me a value of 1.567-ish. Oh, that's very close. So that makes perfect sense. And I can find the upper bound, for example, by just adding 2 times the standard error. And that gives me about 3.1, 3.2. So as you can see, it's just our usual convention and ideas about the confidence interval and the coefficient and the standard error, but now we're doing it in regression. So you can always just use this confint command, and that's just fine. But you can always approximate it just by looking at our standard error and going 2 standard errors above and 2 standard errors below. Great. The third thing, I'm going to skip. You can read through it if you want. I give you some tools to find a prediction interval for an individual observation. I'm not going to do prediction intervals in this class because I don't think it needs our attention, but it's talked about in the book, and I wanted to at least give you the skill to look into it if you want to. So feel free to read through prediction intervals, and again, it's for an individual observation, not just the whole data frame or a coefficient. So feel free to look through that and ask me questions. Lastly, I want to give you a more sophisticated way to look for outliers. And what we're going to do is use the standardized residuals. So remember when we did residuals before, and we used the resid command, it gave me the raw residuals, y minus y hat. And here they all are, all 30 of them. Well, the thing is, these raw residuals, yes, they have a mean that's about 0, but they have a standard deviation that is 8.92, and that's useful. But if I want to look for outliers, I want a more standardized way to know how far away these residuals are to see if an error is an outlier or not. So there's actually a really nice thing that this R standard does. So if I do R standard on my model, what it does is it gives me the residuals that have been standardized. In other words, each residual just divided by basically about 8.924. All it's doing is saying take each residual and divide it by the standard deviation of the raw residuals. And I'll show you why this is useful. The mean is still about 0. But the standard deviation of these standardized residuals is about 1. That's really useful because what we can do, and I'm just going to collect some things that you've seen before here. What we can do, here's a plot that we've seen before of our predicted y values and now our standardized residuals. What we can do is we can say, I don't want any standardized residual above 2 or 3. Any standardized residual above or below 2 or above or below 3 could then be considered an outlier. And the nice thing about standardizing is that I can always use a cutoff of 2 or 3. When I have my raw residuals, these are all over the map and they're not standardized in any way. So if I try to make a cutoff for what counts as an outlier in my errors, I have to change it for each situation. But when I standardize and just look at the standardized residuals, they're always going to follow a certain distribution. They're always going to have a standard deviation of 1. And what I can do, as you see, I'm just adding a bunch of lines to my plot here. I can add in cutoffs to say, hey, there's a potential outlier. There's a potential outlier. So going forward, if you want to check for outliers in your errors, and this, say, can affect normality, it can also affect constant variance. If you've got big outliers in your errors, then you know that there might be some problems with our assumptions. But you can only do this with the standard errors because we know that they will always be consistently standardized to have a standard deviation of 1. So ask me more questions about that if you like, but this is all here for your use when you need to. Thank you.